Hi, this is Aziz Khan, and in this session, we will learn about different multi-path recommendations that we use in path loss. So let me take you in a random link. Let's go to link. So let's see this link. We can see that it's a generally planned link. I mean, not very bad. 8 kilometer link, and we have almost all the values. 99.99 availability. So let's see that how different kind of multi-path calculations, how they affect the availability of this link. So as we can see that the link is currently using this Vigant's per net way of calculation. Let's click it. When you click it, this window opens. This window you can open from here as well. So when you open from here, you can go to multipath, come in the same window. This same window you can directly open from here. So this is the window. If you see this part, this is basic multipath fed algorithm. So which algorithm you want to use, you can select from this part. And you can select any one of these. Some has different internal options as well, like these two. Some like these are ITU recommendations, so they don't have any further thing. They can just calculate based on the ITU recommendation. Then there are some other things, like for example, worst month to annual, how you make it. I mean, you take average annual temperature or you take the ITURP recommendation 530. Also, this one thing is dependent on the antenna and radio files that you have. The files, if they have the dispersive fade margin values, then this will be calculated from the file. Like you want to use the DFM or you want to use the equipment signature. If you run it and it fails and it says to you that dispersive fade margin value is not available, either you can put it manually as well or you can just ignore it from here. So it's up to you. Let me keep it as it is. Fade calculation, you want the fade to be calculated for all the fade margins, or if the fade margin is less than 25 dB and not above 25 dB. Enable co-channel operation, I will unselect it because I don't have a co-channel radio right now, but if you have a link which is co-channel, then you should put co-channel here. Obstruction fading method, you will keep it if there is something that you feel that it can obstruct the path of your waves, then you should calculate it. Currently it is do not calculate, it will not calculate it. So this is the way. So these are the things which you can select on this window. And the main thing is this basic multipath fade algorithm, which is Vigant's Burnett as we can see it. There are two options. That terrain roughness method you can use as sea level or least square feet. I will not go in technical detail of these things apart from very little one, but I will not go in much detail. Also, you can tell it that you want to use the central part of the terrain or you want to use almost all of the terrain. So this is also up to you, and it will make some calculation based on these things. So we are on Vigant's Burnett and we have the all normal things, and we see that we have a 99.999. So this is the link. Now let's change it and let's see that what kind of differences we can see. I will not make any other change in the link for any reason. I will just change these all values of the multipath fade algorithm, and we will just see that what are the difference on the link and what are the different things. Just to let you know that this Vigant's Burnett, if you see here, this needs a C factor to be calculated. When I had initially made the link, I put everything. For a new link, you have to calculate this value, the C factor value. And if it is not there, then it will not get these values. I mean, so you bring it by first bringing the terrain roughness, then the climatic factor, and then this is automatically calculated. If you calculate it directly, then it can directly calculate, but it will bring us some more better value. I directly calculated, bring the C factor of 4, which brings it to 6 nines. When I come from here, first I go to terrain roughness, and then I bring climatic factor, then it comes down to 2.56, and this is also 6 nines in this as well. But whatever, I mean, I will not go in that detail. I'm just trying to tell you that what are the ways, I mean, what you click, how do you go through in these things. Like as I told you, that when you directly calculate it, it brings a direct value. When you come through the above two values, then it brings a bit of different value. But this is how you calculate the C factor, which is required when you want calculate based on Vigant's Burnett path profile data. So this was the first one. Then we have ITURP 530-6. So I clicked on it. I say yes. Now you see this has all gone. This is a cross here. But we know that because when we are using this different recommendations here, then the C factor or something related to the terrain is always changing. So we don't have to go and check. I mean, you can click on it. It will tell you that missing grazing angle, which we should know. I mean, when I click here, you see the grazing angle is M. I will just click it. Now it wants me to give a grazing angle, but for grazing angle, it wants me to define the plane. To define the plane, you have to click left button and the right button on two extents of the map. I can click it anywhere from here to here also it will define, or if I click from here to here also it will define. So it's up to you that from where to where you want the plane to be defined. So this is a kind of average of the height, so that it will use this average height to make the calculation for multipath. So whenever I'm fine with it, I will say yes. It took the value, and when I will say yes, so you see it becomes perfect when to 100. So it means that ITURP 530-6 is very lenient, and it shows you that the link has very high availability. Or you can, if you feel that this is not very good, you can change these values and you can recalculate, but there was not big difference. So we can assume that ITU 536 is quite lenient. Let's go to 537/8. So 7/8 is automatically calculated. Let's see the value it's using. This probability dn by dh. Okay, when I recalculated, because it calculated based on the previous value. So whenever you are in such area where things are previously filled, it is better that you recalculate everything. Like we calculate, so this value was recalculated. Also, we can change this. This is a low altitude antenna in the plains. We can change it to any other value. Like we can assume that these are hills or plains or mountains. Based on these, it will change. It's low altitude. Let me make it a medium altitude and recalculate. It's almost the same value. But as I told you, I will not go in a lot of detail. But you see this, that this has come down from 100. It's all nines, but at least it's not 100. So it means that it's a bit stricter than 530-6. Let's go in the other one. This is 9/12. So again, this becomes empty. Let's click here. So it is using another method, area roughness over 100 into 100 kilometers. So it's using a different kind of factor. So when I click it, it says that okay, area roughness should be 59.54. Whatever is calculated, I will say yes. So it took a value, and if we see, it's almost same. So basically our link is quite small, so that's why we are not able to see any appreciable differences. Otherwise, it should, if it should have been a bigger link, like bigger than 10 or 12 kilometers, then we could see very minute changes between, because on the small links transmission works very well. But nevertheless, our main issue was, I just wanted to show you that how these are calculated. For example, if you are using 539/12, then as I told you, you need to calculate the area roughness. You can click on other values as well, but they are same almost. So let's go to the next one. Now, as you see, as I change it to 530/13, this method automatically changed to ITURP 530. I can take it back to this, but it means that the default of this is this method. So we should keep it as it is. We should keep the defaults as it is. So this, you can also see that this is automatically calculated. We don't have to do anything, but let me just click. So it means that it is using the same values as the previous one. It's not using any different value. So it's again giving us 100%. So this is also not very strict, I will say. Let's go to the last one in the ITU recommendations. So let's see, it is also automatically calculated, but if you see, it has reduced it a very little bit, 99.99998. So it means that ITUR P530-18 is the most strictest in the ITUR recommendation. This is the more newest as well. The values that this is calculating is automatically calculated because we were calculating these values previously, so it has used the same values, and we can just, what the math, the reason of this video was just to let you know that how we can calculate different kind of ITU recommendations. We can use different kind of methods for calculation of the multipath. I will not go in a lot of detail because I told you this detail is a bit detailed thing, but we should go to the last one. You can say that we have three kind of methods. One was Wiegand-Sperner, which is known as a US method. These were the ITU recommendation, and then this is KQ factor. KQ factor is, if I go in KQ factor, it again become empty. I will have to provide the KQ factor here. KQ factor is basically a very small number. Let me give a random number. I'm not sure what should be the value for this area, but I give a number of very small, 0.00001, and you see that this is has calculated as 99.999. Let me take you to the last option just to finish this. So when we calculate this from this KQ factor and I click on it and then go here, then we have to provide KQ value. This will take this value which I provide here and use the other components. If you remember here, we have these frequency and distance component as well. And this KQ value is calculated from a small formula which has the KQ value and then S to the power of 1.3. This S is a constant number between 6 and 42. And you need to calculate this value and provide this value here. So this thing should be calculated from KQ multiplied by S to the power of minus 1.3, where S is a constant value. So you have to know these values for your terrain, or you have to assume and experience value somehow that what value you want to use, and then you can provide these values, and based on that whatever number comes you can here, and then it will calculate it. Doing all these things in front of you was just to show you that what are the different options available, how they are generally calculated, and let me take you to only one additional learning of this. Hopefully you should have at least know that how these are calculated and what kind of different values of are required. Like for example, most of the time generally we use vegans. So vegans needs a C factor value which can be directly calculated or which can be calculated through these two other values. And the ITU recommendation, they either use the grazing angle or they use also some kind of calculation. KQ factor needs a KQ factor. So I think that we are fine here. I hope you should have some idea that how we can use different type of method. So as you see the ITU recommendation, so let me take you to the ITU recommendations, and you can see here that all the previous recommendations are listed here. Like this is P530-6 that we used initially. It's a 1995 recommendation, very old. 7 is 97, 8 is 99, 9 is 2001. Similarly, 16 is 2015, 17 is 2017. This is the one that we are, this which is the newest, which was brought in 2021. This is also 4 years old, but so let me go in that. Let me just show it to you. So this is the ITU recommendation P530-18. It's a programming data and prediction method required for design of terrestrial line of sight system. So basically it's a recommendation which gives you some idea that how a line of sight system should be calculated and how the probability of an outage can be calculated on it. It has some graphs, like for example, this graph gives you a k value based on the path length. So if we have a bigger path, then k goes towards 1.1. If we have a smaller path, then k value is quite small. So there are then different type of formulas. For example, this is the percentage of time that fade depth is exceeded in the average worst month. This is the thing that generally is used to make your availability values. And if you see here, basically what we see from these, because path loss calculate all of these formulas automatically. These formulas are inside path loss. But why we want to see it, or why we go to it, is that we just want to see that, okay, this is dependent on what. So we can see that, for example, this percentage of time is dependent on the frequency, the altitude of lower antenna, and the sub-refractive parameter, which is again calculated using this thing, which again has some height and some distance and something. So we just understand from it that, okay, what things basically change most of it. So for example, if we increase the height, then it should be better for the link, or if we reduce the total length, it should be better for the link. These kind of things we can infer from these formulas. Otherwise, just going through these formulas is not very beneficial, or we have to study a lot maybe. And then if someone has done a kind of degree in transmission in math and physics, and he can understand these things much better. But as a normal engineer, I mean, we know that path loss uses these to calculate this availability, but at least we can understand that, okay, the height of antenna matters. I mean, the distance of the link, the total distance length of the link, it also matters. So we can try to optimize these values and bring a better change in our link. So I hope that this video should be beneficial for you. You should have learned from it. If you have any question, then please write in the comment, and let's meet in some other video. Bye.